a Zoom lecture on series circuit. You should be able to find other videos here shortly explaining series circuit as well. But we know in series circuit, Kirchhoff has a law, and it says that the current is the same throughout the circuit. So with this circuit, my current is coming from top and going to bottom, from my negative to my positive terminal. So Kirchhoff law says IT is equal to IR1, which is equal to IR2. It also says that volt total, VT, is equal to VR1 plus VR2. And RT, our resistance total, is equal to R1 plus R2, etc. So I always teach students, we're going to solve this electrical circuit. It has three loads. It has RB1, RB2, and RB3 in series with a 6-volt power supply. It gives us a few values for R1, R3, and R2. So at the end of the day, RB is just identifying the different loads. So I encourage students to do this. First and foremost, write down your columns and it'll speak. In this case, we cannot start with our totals. So first thing I want you to do is write down your columns. So we got RB1, and what did they give us? They told us 2 volts. So we don't know the resistance, but VRB1, which is the voltage drop across RB1, is 2 volts. And we don't know IRB1, the current. We don't know it. So we leave it there. We got that column for RB1. So next, let's do RB2. So write down your columns. Resistor for bulb 2. They gave us that is 60 ohms. That is given. So now we need to know what is the voltage drop for RB2. And also what is the current for RB2. We don't know any of that, so we see we only have one piece of each of the pie for each load. So then let's go to RB3. RB3 is equal to, we don't know it. They only gave us VRB3. They only gave us the voltage drop at that load, which is 1 volt. So we don't know IRB3. All right, so looking at this, if I know that I have 6 volts going in, right? 2 volts go to RB1, 1 volt go to RB3. So 2 plus 1 is 3. So I know my second load is getting 3 volts. Why? Because 2 plus 3 plus 1 is equal to 6 volts. All right, so now that I have 2 pieces of this pie, I can find the third piece, Ohm's law. So IRB2 is equal to VRB2 divided by RB. So is your voltage divided by your resistance. In this case, we have 3 volts. We're going to divide that by 60 ohms. Now, let's see how much current we have. In our calculator, we will push 3 divide by 60 equals. It gives me 0.05. I'm going to put that in engineering notation, so I hit shift, divide, 50 milliamps. So we have 50 milliamps of current running through this circuit. So I can go on up here and say, okay, we got 50 milliamps of current running through the circuit. So now that I know Kirchhoff's law for a series circuit says the same 50 milliamps is going to go to RB2, 3 RB2 and RB1 and return back to its the power supply. So at the end of the day, I can go on and fill in for IRB1. That's 50 milliamps. I can go on and fill in for IRB3. That's 50 milliamps. Why, Ms. Johnson? Because the current is the same. So now that I have 2 pieces of my pie, I can find a third one. So RB1 is equal to VRB1, your voltage across that load, divided by your current. And we put the numbers in. You got 2 volts divided by 50 milliamps. So I go to my calculator, clear it out. I got 2 divided by 50 milli, exponent 3, and I'm going to change it to negative, equals, I got 40 ohms. So RB is equal to 40 ohms. 40 ohms. All right. So I go over here. I'm going to write that there, 40 ohms. I go over here and I can find RB3. RB3 is equal to VRB3, the voltage drop, divided by the current. If I put in my numbers, I have 1 volt divided by 50. Let's see. So let's see what that value is. So clear out my calculator. XP3 negative equals, I have 20 ohms. So now I can calculate my resistance total and see if my numbers are correct. So now I'm dealing with Ohm's law but the totals. So I know that VT is equal to 6 volts. Why? Because it's by my power supply. My IT is equal to 50 milliamps. How do I know that? We calculate, verify if it's correct. So my RT would equal my VT divided by my IT, which is equal to 6 volts divided by 50 milliamps. And I put that into my calculator. I clear it out from last usage. 6 divided by 50 exponent 3 negative equals, I have 120 ohms. So my RT is 120 ohms. But let me verify that. I'm going to verify it, and I'm going to use a formula, another formula. T is equal to 6 volts. So we know that VT is equal to IT times RT. Let's look at it. All right, so we got 50 milliamps that we're going to multiply by 120 ohms. We should get 6 volts. Let's verify it. So we got 50 exponent 3 negative times 120 equals 6 volts. So that lets me know. Now, one last thing that I want to say about this circuit is we could have calculated the power total, PT. We could have used the formulas power is equal to I times V. We could have multiplied our current times our voltage. So let me show you. PT, power total, is equal to IT times VT, which is equal to my 50 milliamps times my 6 volts. And let's see how much I get for my power total. So I clear my calculator out. I have 50 exponent 3 negative, and I multiply that by 6. I get 0.3 watts. But we know we can always hit shift divide, and that says, Ms. Johnson, 0.3 watts is the same as 300 milliwatts. Okay? So at the end of the day, we can calculate our power total. But what that means is if you got 0.3 watts, this is getting some power, that one is getting some power, and that one's getting some power. So for each load, you could have calculated the power going through resistor 1, 2, and 3. I want you all to look at this video, and I pray that this video help you to be able to accomplish those homework assignments. We will do more videos and have more videos posted. Always remember, you can do it.